All right, so in this section, 7.2, we're going to look at properties of functions. Okay, so first property is injection. Okay, so we're going to see what an injection or injective function means. All right, so an injective function is what we know as a one-to-one function from algebra. Okay, so here's kind of the definition of it. If A is a function from set A to set B, it's injective if for all A, B in A, if A is not equal to B, then f of A is not equal to f of B, right? This is logically equivalent to saying this. Okay, so this is saying that if two images are equal to each other, then they must have come from the same point. So if f of A equals f of B, then that means that A equals to B. Okay? In other words, a one-to-one function or an injection, for each x value, you have one y value. For each y value, you have one x value. So it's a one-to-one correspondence. So there's no doubling up, right? So you can have like a y value that comes from two different x values either, okay? Already for a function, you can have one x value that goes to two separate y values. For an injection, you can have a y value that came from two separate y values. So one-to-one correspondence. Okay, so first example, let's look at this a function that's represented by this arrow diagram and see if it's one-to-one. Right? So we can see that it is one-to-one because each, like the x values that are in the domain, they're all used, which is good, right? So it's a condition for a function. And each x values go to a unique y value, and each y value has a unique input. So there's a one-to-one correspondence. Okay, so this is a yes. Example 2, let's look at the function f of x equals x squared from the set of integers to the set of integers. Okay, so this is not a one-to-one function, right? And you can see examples for that is because let's say I plug in 1, or 1 squared is going to be equal to 1, but if I plug in -1, this also gives me 1, okay? So you get, for any arbitrary x, if you plug x in there, you're going to get x squared, but if you also plug the negative of it, you're also going to get x squared. So there's not a one-to-one correspondence, right? Again, this could be easily fixed if you restrict the domain. Okay, so if I restrict the domain to be from the set of positive integers, then over that domain, it would be an injection. It would be a one-to-one function. Okay, so one-to-one functions are very important. Injections are important because those kinds of functions have inverses. You can invert them. So that's why we're investigating them. That's why we're looking at them. So if a function is not one-to-one, such as in this case, you gotta restrict the domain. You gotta sort of take portions of the domain and say, oh, it's an injection of over this part of the domain, and then I can invert it. Let's look at the next function. So I have a function from domain A, B, C, D to codomain 1, 2, 3, 4, 5, and the function rules are listed, right? So let's draw an arrow diagram because it's useful to see. So my inputs are A, B, C, D, and my outputs are 1, 2, 3, 4, 5. So domain and codomain. And let's draw arrows. So it says f of A is 4. So that means that A goes into 4. 4 is the image of A. B goes into 5. 5 is the image of B. C goes into 1. And D goes into 3. Okay, good. So this looks like a one-to-one function. It looks like an injection. because like each of the y values that are images are only associated with a unique x value. So there's no y value that could come from two different x values. So that's the definition of an injection. My next definition is a surjective function or a surjection. Okay, so a function is surjective if its range is equal to its codomain, right? And this is called the onto function. So in algebra pre-calc somewhere, you might have encountered onto functions. Okay, so this is not widely discussed in like a regular algebra or pre-calc class, but some of you might have heard of it. Basically, an onto function is a function that the codomain is equal to the range. Right? So basically, when you look at all the values of the range, they are all images of elements in the domain. So basically, the whole range is used up. There's no elements in the range that are not used up. They're not images. All right, so let's look at this example. Is the following function onto? So again, start with the arrow diagram. It's really helpful to see. So basically, we want to look at, this is the codomain right here, values in the codomain, and they're all used up, like arrows are going to all of them. That means they're all images of elements in the domain. So that means this is also the range. So because the codomain equals to the range in this case, this function is onto. It's a surjection. Okay? It's not one-to-one because we can see that the value of y is associated with two values of x, but it's definitely onto. Okay, let's look at example 5. So let's determine whether the function f of x equals x squared from the set of integers to the set of integers is onto. Okay, so here's we're looking from the set of integers to the set of integers. So this is my domain and this is my codomain. Okay, so the codomain as specified is the set of integers. Now let's see what the range is. Okay, so if I look at my function f of x equals x squared, I see that the outputs can only be positive integers or non-negative integers. It could be 0. Okay, so the range is non-negative integers, which is z plus the 0 included. So because the codomain is not equal to the range, this is not an onto function, not a surjection. Let's now look at this function, which is defined from A, B, C, D. So this is the domain, 2, 1, 2, 3. This is the codomain. This is the domain, and this is the codomain. With these rules, okay? So I'm going to draw an arrow diagram because it helps me visualize. So if I have A, B, C, D are my domain values, and 1, 2, 3 are my range values. We're going to draw arrows to see how they're connected. So A goes to the image 3, B goes to the image 2, C goes to 1, and D goes to 3. Okay? So because all the values in my codomain are images, then this is also the range. And because they're equal to each other, then this is going to be an onto function. Okay. Again, you try to see if a function is onto or surjective because we want to be able to invert functions. Okay, so inverting functions means that you're going to go backwards, like your domain and codomain get interchanged. Okay, so the functions that are invertible they need to be both injections and surjections because of these two rules for functions, okay? So this kind of takes into account that first rule that all the values in the domain need to be used, right? So when we invert it, when my codomain becomes my domain, they all need to be connected with something in the in elements in the domain in order for the inverse to fulfill the function rule. All right, so we call a function that's both injective and surjective, we call it a bijective function. All right, so something bijective functions are one-to-one onto functions. So bijective functions have both of those properties. So let's look at these functions. So I have 1, 2, 3, 4, 5 arrow diagrams representing relations, and we want to see what they are. Okay, so let's see. The first one right here, right, it's a function because it uses all the values in the domain, and there's only one arrow coming out of each of them. It is one-to-one, okay, because each y value is associated with just one x value, but it's not onto. Okay, so this is 1-to-1, but not onto. Okay, so this one here, it's onto because all the y values are used, but it's not 1-to-1 because the y is 2 comes from two different x's. So this is not 1-to-1, but it's onto. Okay, let's look at this one. This one, all the y values are used, and all of them come from a different x, right? So this is both 1-to-1 and onto, so it's a bijection. Okay, so this is 1-to-1 and onto, so this one is a bijection. All right, let's look at the next one. So this one is neither, right? Because it's not onto because 4 is not used, and it's not 1-to-1 because 2 is used twice. Okay, so this is not 1-to-1, and it's not onto, so it's neither of those things. All right, now let's look at the last one. And I noticed that this is not a function at all because of that a. Okay, so this is not a function to start with, so you don't want to call it 1-to-1 or onto because it's not a function. It's not a function because a is associated with two y values. It breaks that condition number 2. All right, example 8 says determine whether the function f from a, b, c, d to 1, 2, 3, 4 is a bijection. Let's do the arrow diagram here. Those can be done without the arrow diagram, just by looking at the numbers. But I like drawing them because it just helps visualize. You can see it a lot quicker. Or better, or something. I just like arrows. So f of a goes to 4. And f of b goes to 2. F of c goes to 1. F of d goes to 3. Okay, so this is bijection because all the y values in the codomain are used, they're images, and they also belong to different x's, right? So they're only used once. Okay, so it's a bijection. Perfect.